of this question. Next one, another beautiful question, sir. Question, n equivalent to 1, 2, 3, 4. It is a 4-digit number. Again 1, 2, 3, 4. Okay, 1, 2, 3, 4. 1, 2, 3, 4. Written 30 times. Written 30 times. Written 30 times. Here previous problem 5, 6, 7, 8, 9, it is a 5-digit number. So I am checking for 10 power 5. Here 1, 2, 3, 4, it is a 4-digit number. Let me check what will happen. 10 power 4 divided by 73. 10 power 4 divided by 73. Now see here. 10 power 4 can be written as 10 square into 10 square. 10 square into 10 square divided by 73. 100 divided by 73. 73 ones are 73. Remainder 27. 27 into 73 ones are 73. Remainder 27. 27 into 27. 27 square is 729. 729 divided by 73. 73 tens are 730. What is the negative remainder? -1. What is the negative remainder? -1. Because it's a 4-digit number, idea is to check whether 10 power 4 divided by 73. Similarly, 10 power 4 divided by 137. 10 power 4 divided by 137. This is 10 square into 10 square divided by 137. 100 divided by 137 minus 137. Minus 37. It is also minus 37 divided by 137. 37 square 1369. Divided by 137. 137 tens are 1370. Negative remainder is -1. That means idea is 10 power 4 divided by 73, it is -1. 10 power 4 divided by 73, it is -1. 10 power 4 divided by 137, it is -1. 10 power 4 divided by 73, it is -1. 10 power 4 divided by 137, it is -1. It is -1. So what will be the divisibility rule for 73 and 137? Divisibility rule for 73 and 137. We have to start from right hand side. Start from right hand side. Start from right hand side. Take a group of 4 digits. Take a group of 4 digits. Alternatively add and subtract. Take a group of 4 digits. Alternatively add and subtract. Alternatively add and subtract. Alternatively add and subtract. That is the divisibility rule for 73 and 137. From where I got this idea? I just asked myself, why this 4-digit number is getting repeatedly? Is there any possibility for 10 power 4 divided by 73? 10 power 4 divided by 73, it is -1. 10 square, 73 ones are 73. 27 square, 100. 27 square 729. 73 tens are 730. -1. Similarly for 137. That means if the question is 1, 2, 3, 4, 1, 2, 3, 4, if it is written 2 times divided by 73 or 137, take a group of 4 digits alternatively plus minus. 1, 2, 3, 4 minus 1, 2, 3, 4. Remainder it is 0. That means any 4-digit number, please make a note of it, sir. Any 4-digit number written even number of times. Any 4-digit number written even number of times. Even number of times. It is always divisible by 73 and 137. Any 4-digit number written even number of times, it is always divisible by 73 and 137. 1, 2, 3, 4, it is a 4-digit number. It is written even number of times. So answer for the first question is 0. Answer for the second question, it is also 0. Answer for the second question, it is also 0. Whenever if you see the question, a 4-digit number is getting repeated, check with 10 power 4 by the question asked. If a 5-digit number, if it is getting repeated and question is asking for a particular number, check for the 10 power 5. Very beautiful questions. Divisibility rule for 73 and 137. What is the divisibility rule for 73 and 137? Start from unit digit. Take a group of 5 digits. Alternatively add and subtract. What is the divisibility rule for 41 and 271? Start from right hand side. Take a group of 4 digits and add them. Take a group of 4 digits and add them. I hope the idea it is clear. Now, write down this note. Another some important concepts related to divided by p. Reminder. A power p minus 1 divided by p, it is equivalent to 1 when a and p are co-prime. When a and p are co-prime and p is a prime number. And p is a prime number. P is a prime number. This is a Fermat's theorem. From Fermat's theorem, an extremely important conclusion can be drawn. What is that conclusion? Let us see. Reminder, 10 power p minus 1 divided by p, it is equivalent to 1. A and b should, 10 and p should be co-prime. So p should not take 2 comma 5. P should not take 2 comma 5. P should not take 2 comma 5. If it goes to the right hand side, this will become 10 power p minus 1 minus 1 by p. 10 power p minus 1 divided by p is 1. 1 minus 1, it is 0. So 10 power p minus 1 minus 1 divided by p. Reminder, it is 0. Let me take p value 3. If I take p value 3, this will become 10 square minus 1 by 3. 100 minus 1 is 99. 9 into 1 divided by 3. 9 is perfectly divisible by 3. 9 is perfectly divisible. P equivalent to 7 if I take. This is 7 minus 1, 6. 10 power 6 minus 1 by 7. 10 power 6 minus 1 is 9 into 6 once divided by 7. 9 is not divisible. So this should be divisible. Yes or no? These 6 once divided by 7. Now if you see here, p should not be equivalent to 2 and 5. Why? Because these both the numbers should be co-prime to each other. P should not be equivalent to 3 because if p is 3, 9 is a multiple of 3. Please write down. Very, very important key point. Any non-zero digit written p minus 1 times, any non-zero digit written p minus 1 times is always divisible by p. Any non-zero digit written p minus 1 times is always divisible by p if p is prime. If p is prime, p not equivalent to 235. P not equivalent to 235. Very, very important key point. By knowing this key point, you can solve a lot of questions very, very fast. Any non-zero digit written p minus 1 times. Think logically, sir. If p is equivalent to 11, this is 10 power 10 minus 1 by 11. This is 9 into 111111 divided by 11. 9 is not divisible. 11111 is written 10 times. Sum of the odd places 5. 5 ones, sum of the even places 5 ones. It is divisible. Now see here. Denominator it is 11. 1 is written how many times here? 10 times. That is what I wrote. Any non-zero digit. Very, very important, sir. any non-zero digit written p minus 1 times, it is always divisible by p. P not equivalent to 2, 3 and 5. P not equivalent to 2 and 5. Why? Because 10 and p should be co-prime to each other. Why p not equivalent to 3? Because if p is equivalent to 3, 9 is divisible by 3. So I am starting beyond 2, 3 and 5. Beyond 2, 3 and 5. Beyond 2, 3 and 5. If the denominator contains a prime number, numerator digit should be repeated p minus 1 times for it to be perfectly divisible. If the denominator p is a prime number, non-zero digits should get repeated p minus 1 times. P minus 1 times. Now see here. Question is 7, 7, 7, 7, 7. Easily you can solve. 7, 7, 7, 7 written 50 times divided by 17. Divided by 17. Read the note. Is the denominator a prime number? Definitely yes. If the denominator it is a prime number, numerator should be repeated p minus 1 times. 17 minus 1 times 16 times. That means if 7 is written 16 times, perfectly divisible by 17. How many 16 will go up to 50? 16 3s are 48 times. If it is 48 times, answer would have been perfectly divisible. How many are left? 2 more 7s are left. 77 divided by 17. 17 4s are 68. Remainder it is 9. I hope the idea it is clear. 7, 7, 7 written 50 times divided by 17. 17, numerator should be written 16 times. 16 times perfectly divisible. 16, 3s are 48 times. Remaining it is 7. 77 divided by 17. 17, 4s are 68. Remainder it is 9. Any non-zero digit, very, very important key point, sir. Any non-zero digit written p minus 1 times, it is always divisible by p if the remainder p is not equivalent to 2, 3 and 5. In fact, in this question also you can use it. See here. See here. For example, this question. 259 is 7 into 37. Denominator it is 7. If it is 7, numerator should be of 7 minus 1 6 times. 6 times 0. 6 12s are 72. Remainder it is one more remainder it is there. Remainder 4. If the denominator it is 37. If it is 37, numerator should be 36 times. 36 2s are 72 times. One more 4 is left. One more 4 is left. Idea it is clear. If the denominator it is p, the non-zero digit should be repeated p minus 1 times. Now, easily you can solve all the questions. Number is divided by 19. 19. When a denominator it is a prime number, non-zero digit should be repeated p minus 1 times. If the question is 18 times, if 8 is written 18 times divided by 19, answer would have been 0. Answer would have been 0. 18, how many times it will go? 18 4s are 72. 3 more 8s are left. 888 divided by 19. 19 4s are 76. 128. 128. 19 6s are 114. Remainder it is 14. Remainder it is 14. 19 4s are 76. 128. 19 6s are 114. Remainder it is 14. 18 times it is 0. 36 times it is 0. 54 times it is 0. 72 times it is 0. Remaining 3 8s are left. 3 8s divided by 19. Easy question. Next question. N is divided by 67. N is divided by 67. What will be the remainder? If it is 67 times, numerator should be, have non-zero digit should be written 66 times. 66 times divided by 67 It is 0. 66 twos are 132 times. So answer is 555 divided by 67. 555 divided by 67. 67. 8s are 7 8s are 56. 48 536. Remainder it is 19. Very easy. If the denominator it is a prime number, non-zero digit should be repeated p minus 1 times if p is prime. 67 times, 66 times, 66 twos are 132. Remainder 3. Idea clear? Next one. Another question. N is a 50 digit number. Okay. N is a 50 digit number. N is a 50 digit number. All the digits except the 26th digit. All the digits except the 26th digits are 1. All the digits except the. It is 1. This is the 26th digit. All the digits except the 26th digits. All other are 1. Given that the number is divisible by 13. Given that the number is divisible by 13. Number is divisible by 13. See here. Number is divisible by 13. Remainder it is 0. Seems like a mock question, but it is a very easy question. What is the concept we discussed? If a number is divided by 13, the non-zero digit should be repeated how many times? 12 times. That means 12 times it would have been 0. 24 times it would have been 0. 25th digit. 26th digit. I don't know. 26. Again it is 1 is written 12 times. Again it is 1 is written 12 times. 1 is written 12 times. Can I do like this? Total 50 digits are there. Total 50 digits are there. 50 digits. Because n is divided by 13. If it is divided by 13, a non-zero digit repeated p minus 1 times, 12 times. 12 times it would have been 0. 24 times it would have been 0. Break it into a groups of 12. So 24 here it will be there. 24 here it will be there. 12 digits, 12 digits. 12 digits, 12 digits. 12, 12, 24. 26th digit, right? So this is 1 and it is x. Digits from the left. So let me erase it. I hope the idea it is clear. Just a simple question, sir. 1x. This entire number is divisible by 13. 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 12 digits, 12 digits, 24 digits. 25th digit, 26th digit. I want 26th digit. So this should be 1x should be divisible by 13. 1x should be divisible by 13. What is the value of x? X is 3. Yes or no? Very easy question. A number divided by 13. If a number divided by 13 and the number consists of the single digits getting repeated, so any digit written p minus 1 times, it is perfectly divisible. So 1 written 12 times 0, 1 written 12 times 0. 24 digits at 0. 25th only it consists of 1. 26th I want. Again 12 and 12. 48 groups I got 0. 1x should be divisible by 13. X value it is 3. Yes or no? Very easy if you read the question and try to convert the question. There is a number less than 10 power 100. 10 square it is 100. Number less than 100. The maximum value of a number less than 100 is 99. It will have 2 digits. It will have 2 digits. Suppose if it is 10 cube. 10 cube it is 1000. A number less than 1000. What is the maximum value just less than 1000? It is 999. 999. How many maximum digits it can have? 3 digits it can have. So 10 square, maximum digits is 2 digits. 10 cube, maximum digits less than 10 cube, it is 3 digits. So if a number is less than 10 power 100, 10 power 100, 10 power 100, 10 square, maximum digits is 2 nines, 2 digits. So this is n maximum, it will be 10. N maximum it will be 99999 100 digits. 100 digits. So maximum value will have 100 digits and is divisible by 17. So n will have maximum 100 digits. N will have maximum 100 digits. Okay. What is the question? How many values of n are possible if n is and it is divisible by 17. If n is divisible by 17, what is that we discussed right now? If a number is divided by 17, what will be the answer? P minus 1 times. That means 3 is written 16 times. 3 is written 16 times. It is perfectly divisible by 17. Yes or no? 16 times it will be divisible. 16 times it will be divisible. How? 32 times it will be divisible. 48 times it will be divisible. Like that. 96 times it will be divisible. So answer is, how many values of n are possible? 6 values they are possible. What are that values? 3 is written 16 times. What is the next value? 3 is written 32 times. Next value, 3 is written 48 times, and so on up to 3 is written 96 times. 96 times. The maximum number of digits n can carry, it is 100 digits. If I take the next multiple of 16 beyond 96, 16 sevens are 102 digits I will have. Very, very easy question. It is not a difficult question. There is a number less than 10 power 100. So if I take 10 square, the maximum value it is 99, which will have 2 digits. If I take 10 cube, the maximum value it will have will be 3 digits. If I take a number less than 10 power 100, the maximum number of digits it will have is 100 digits. That will give us an upper cap on the question. And the number is divisible by 17. Number is formed by only 3's. Any non-zero digit written p minus 1 times, it is always divisible by p if p is a prime number. So 16 times it is divisible, 32 times it is divisible, 96 times it is divisible. 16 6 are 96 times it is divisible. Beyond 96 you should not take, because it will result in 102 digits. I hope the idea it is clear. Answer for this question is 6 digits. Answer for this question is 6 digits. Now here you might do a mistake. The mistake is, a number is less than 10 power 125. That means n maximum value of n will have 125 digits. N maximum value it will have 125 digits and is divisible by 37. And is divisible by 37. Here you might do a mistake. A number is divisible by 37. 37 is a prime number. So 36 times you might take and tick mark the answer as 36. 3s are 108. 3 times you might do. But if you see here, a number is formed by only once. 111 divided by 37. It is 0. 6 ones. It is also divisible. Yesterday in session number 2, I discussed the divisibility rule of 37, one important key point. What is that key point? Any non-zero digit written in groups of 3, it is always divisible by 37. Any non-zero digit written in groups of 3's, it is always divisible by 37. Why it is happening? 37 3s are 111. So 37, a group of 3 ones, it is divisible. So it is, don't take in a hurry, 36 times. For a 37, this is a very, very important property. Any non-zero digit written in groups of 3, it is not 36 times. For 3, even for a group of 3, I will get the answer. Group of 3. So these are divisible by 37. Divisible by 37. 3 times it is the divisible. 6 times it is the divisible. 9 times it is the divisible. 12 times it is the divisible. 125 by 3. Answer is, how many values n can take? 41. In hurry, do not say that the answer is 3. That is the important property for 37. Any non-zero digit written in groups of 3s is always divisible by 37. So 3 times it is divisible, 6 times it is divisible, 9 times it is divisible, 12 times it is divisible, 341 times it is, 123 times it is divisible. I hope the idea it is clear. Now comes the most important property. Sir, we discussed only the divisibility rule for certain numbers. We discussed the divisibility rule for 7, 11, 13. We discussed the divisibility rule for 27, 37. We discussed the divisibility rule for 99, 101. We discussed the divisibility rule for 17, 19, 41, 271, 73, 137. Can we find out the divisibility rule of any prime number? Any prime number, can we find it out? Now see here. Theory of osculation. Theory of osculation. What is this theory? How it helps us? Theory of osculation. Theory of osculation helps us in finding the divisibility rule of any prime number. Divisibility rule of any prime number. By using the theory of osculation, you can find the divisibility rule of any prime number. Divisibility rule of any prime number. So, if B is the unit digit of a number, B is the unit digit of a number, A is the rest of the digits. A is the rest of the digits other than unit digit. Rest of the digits other than unit digit. Listen carefully, sir. Rest of the digits other than unit digit. A is the rest of the digits other than unit digits. Or for simple problems, we will do like this. What we will do is, first we will do it for a 2-digit number, then you can extend it for a 3-digit number. AB. If you can write AB as A plus or minus K into B, A plus or minus K into B, such that A plus or minus K into B will be either be 0 or it will be a multiple of AB or multiple of AB. Theory of osculation is all about finding the value of K. AB, if it is a number, if it is a number, if you can find the K value such that A plus or minus K into B is either 0 or a multiple of AB, then you can find the divisibility rule of a prime number. Then you can find the divisibility rule of a prime number. 2 to 3 examples I will do, then the concept will be clear. First, 7 it is there. We are discussing for a 2-digit number, 7. What are the single digit prime numbers? 2, 3, 5 and 7. These are the 4 single digit prime numbers. 2 it is unit digit should be even. 3 it is sum of the digits should be divisible by 3. 5 it is unit digit should be 0 or 5. So for 7, I will take it into a 2-digit format. What is the first multiple of 7? 14. Can I write 14 as 1 minus 2 into 4? What is 1 minus 8? 1 minus 8 is minus 7. Forget about sign. Is 7 divisible by 7? Yes. So what is the k value here? K value here, it is defined as 2. K value here, it is defined as 2. So I am writing it as a minus 2b. Am I right? A minus 2b. What is the value of k? K value, it is 2. So how it is useful? For example, I need to check whether 1225 is divisible by 7 or not. Is 1225 divisible by 7 or not? I need to check it out whether 1225 is divisible by 7 or not. A minus 2b. Other than the unit digit, rest all the numbers, call it as A. A minus 2b. B is nothing but the unit digit. A minus 2b. 122 minus 2 into 5. 122 minus 10, which is 112. Continue the process. Again it is of the form AB. A minus 2b. AB. 11 minus 2 into 4. 11 minus 4, it is 7. Is 7 divisible by 7? Yes. So therefore, 1225 is a multiple of 7. 1225 is a multiple of 7. I hope the idea it is clear. If it is a number AB, try to write down in the form A plus or minus K into B. What is K value? K is a natural number. K is a natural number. The value of K can change from one value to another value. There are two ways of doing it. Either it is A plus K into B or A minus K into B. That is the reason divisibility rule for a prime number is not unique. Theory of osculation is always about finding the value of K. In what way you can express that number? If you can find the value of K, then you can develop the divisibility rule of a prime number. 7 is a single digit number. Since I took a 2-digit number, I took the multiple of 7, 14. I tried to write it down as this is A and it is B. A minus 2B. K value, it is 2. So if I take other than the unit digit, rest or all the numbers, take it as A. A minus 2B. 122 minus 10, which is 112. Again, other than the unit digit, take it as A. 11 minus 4, 7. Is 7 divisible by 7? Yes. So what is the divisibility rule for 7? Divisibility rule for 7 is A minus 2B. B is the unit digit, A is the rest of the number. B is the unit digit, A is the rest of the number. I hope the idea it is